Hi, welcome to this YouTube revision series on high-yield topics on biostatistics for MRCOG1. I am Dr. Avinash SS, mentoring in the area of biostatistics for StudyMEDIC and StudyMRCOG group. Today, we will be discussing some of the high-yield topics as a revision series for the appearing the biostatistics part 1 examinations. The following are the high-yield topics. So one is the variables. The next high-yield topics would be measures of central tendency and dispersion, and representation of the data using graphs and identification of these graphs, normal distribution and its characteristics, and confidence interval. Many other high-yield topics we shall cover later. Coming to the topics of variables. So variables are characteristics of interest that we observe in a sample. Now, variables can be classified in and measured in various scales. The usual questions that is asked is to identify these variables. Now, what are the variables? Like, for example, gender. So you can see gender. What type of variable is a gender? Either male or a female. You can see that this is a naming variable. Means it names either a noun. It has no grade and or scale or order, and it is very mutually exclusive. So such variables are called as nominal variables. Similar examples of these nominal variables include the types of delivery, like it is LSCS or vaginal, etc. Types of complications and types of presentation, either cephalic, breech, or whatever it is. So these are the examples for nominal variables. Then, for example, socio-economic status. It can be classified into a rank of poor, middle, and rich class. For example, you can see that this variable is ordered and it is scaled or graded or ranked. However, the difference between the scale or grade is not very exact. Meaning, those who are rich does not mean they are twice as rich as those who are in the poor status. So the difference is not exact. The other examples of such ordinal variables includes visual unlock score, pain score, Apgar score, and coma score. Though they are numbers, but they are actually based on a particular criteria, and then it is number. The number is given based on this criteria. So they are all called as the ordinal variables, or variables measured in the ordinal scale. The next numerical variables are either measured in the interval scale, right? Now, for example, temperature in degree Celsius or degree Fahrenheit. Now you can see at 0 degree Celsius usually means actually not an absence of temperature, right? It could be some other degree Fahrenheit, or it could be some other degree in Kelvins. Actually, temperature in Kelvin as a absolute zero. 0 Kelvin actually means minus 273 degrees Celsius. It is the absence of temperature. But 0 degree Celsius does not mean absence of temperature. So it does not have a true zero, right? But the difference between these is very exact. So difference between 15 and 20 and 20 and 25 degrees Celsius is exactly 5 degrees Celsius, and it is very exact. Since there is no true zeros, this cannot be expressed as a ratio. Means we cannot conclude that a temperature with 50 degrees Celsius is twice hotter as compared to the temperature 25 degrees Celsius. Because if we convert it into Fahrenheit, it would seem otherwise. Similarly, IQ scores, SAT scores, pH, etc. are all interval variables with no absolute zero, or zero has no meaning. The other scale or highest scale of measurement of a numerical variable is a ratio scale. For example, age. You can see for this there is a true zero, right? And it can be expressed as a ratio. Means a person who is aged 50 years, you can see is twice older compared to the person who is aged 25 years. We can say that, and it can be expressed as ratios. Similarly, the other examples includes distance, weight, and other derived units of force, pressure, BP, etc. are all examples of ratio variables. Now these variables, which are numerical, sometimes are also based on whether they can assume any values within the spectrum, are divided into discrete or continuous. Now what are these discrete variables? So discrete variables, as the name means, any random numerical variable. For example, number of children. You can see it can assume only whole numerical count. It cannot assume any values other than this whole numerical count in between these values. So in between the two adjacent values, it cannot assume any other value. So it's a whole numerical count, and hence it is a discrete variable. Other examples are live birth, stillbirth number, death number, etc. Whereas the numerical variable, which is actually continuous, measured in it is classified as a continuous. For example, age, height, weight, etc. They can assume any value within the spectrum. Okay, so it can be 164 centimeter also, 165 also, 164.1 also, infinite number of any values it can assume theoretically. They are called as continuous variables. So numerical are either discrete or continuous. Now to summarize, variables are either numerical or categorical. Numerical are measured in ratio and interval scale. They can either be continuous or discrete, whereas categorical are measured either in ordinal or nominal scale. For further details with clear graphical representations, diagrammatic representations, and further other examples, please subscribe to our StudyMEDIC and StudyMRCOG library. The next topic is measures of central tendency. The measures of central tendency, the most commonly used is the mean. We all know mean is nothing but sum of all total numbers. We add all the total numbers and divide it by the total number. For example, if a sample is drawn from a population and the total number of babies in this sample is 3, and the weighs 1 kg, second one 1.1 kg and another one 0.9 kg, the mean weight would be to add all this and divide it by the total number, that is 3, and the mean weight would be 1 kg. This is a very simple calculation. The second measure of central tendency is the median. Now what is this median? Median is the centralmost value in a sorted data. Median is the centralmost value in a sorted data. Now what do you mean by this? If you take this data, if you take the data and the weight of this same data above sample in these children is 1 kg, 1.1 kg and 0.9 kg, if they are the weight, right? And you have to first sort this. You have to first sort this into, you can see after sorting 0.9, 1 and 1.9 in increasing order. Then what is this median weight? Median weight, if n is odd, is calculated as n plus 1 by tooth value. Actually it is n plus 1 by tooth value. Okay, that means our median is the half of n plus 1 to value, n plus 1 by tooth value. Now if you take here, median weight would be 3 plus 1 by tooth value, that is the fourth value, which is equal to, second value, which is equal to 1 kg, right? 1 kg is the median weight. So this is the median value. On either side of this value, equal number of data exists. Okay, now what happens if n is even? If n is even, what will happen? So you can see if n is even, actually it is average of n by tooth value and the next value. For example, we can see here the data is the same, but here one more sample is added. So n is 4, it is even in number. Now what we have to do, we sorted this. After sorting, it is 0.9, 1, 1.1 and 2 kg. Then the median weight would be average of the n by tooth and the next. What is the n by tooth? That is a second value. What is the next? That is the third value, which is equal to 1.05 kg becomes the median. So when n is even, we have to take the average of the two numbers. When n is odd, we have to take 1 by tooth of the n plus 1th value, half of the n plus 1th value. So this is how we calculate the median. So next is the mode. The mode is the most commonly occurring data or frequently occurring data. For example, in this data set, 1 occurs once, 0.9 occurs once, and 1.1 occurs twice. So 1.1 is the mode value of the weight. So these are the measures of central tendency. For more details on measures of central tendency, subscribes to StudyMEDIC. Now there are measures of dispersion. The most commonly used measure of dispersion is actually standard deviation. Standard deviation. Now it is the square root of sum of all squared mean difference. Means what? It is the square root of sum of all differences of all data from the mean value, that is the square differences, divided by n. So this is the standard deviation. More is the standard deviation, more is the variation. Usually it is used along with mean and not with median, and only when the data is normally distributed. Why mean and SD are only used when the data is normally distributed? If you want to know further, subscribe and listen to our StudyMEDIC library. The next measures of dispersion is interquartile range. What is this interquartile range, also called as IQR? It is calculated as quartile 3 minus quartile 1 value. Okay. Now if n is odd, if the number is odd, what is the quartile 3 value? It is a 3/4 of n plus 1th value. Now for example, in this data set where there is weight of the birth weight is recorded, this is the birth weight. Now after sorting this, we can see in increasing order, 500 gram is the least and the 2.8 kg is the highest. Now we have sorted this. Now what is the quartile third? 3/4 of n is 11 here. 3/4 of 11 plus 1. It is equal to the 9th value. So this is the quartile 3 value. What is the quartile 3 value? It is the 2 grams. This is the quartile 3 value. Now what is the quartile 1 value? 1/4 of n plus 1th value. That is the third value. So quartile 1 is 1 kg. Now interquartile range is that range which is quartile 3 minus quartile 1. That means 2 minus 1 is 1 kg. Now that means between this quartile 3 and quartile 1, 50% of the data lies. Between quartile 3 and quartile 1, 50% of the data lies within it. Right? So that is how we calculate the interquartile range. When the data set is even. Now if the when the data set is odd. Now if you want to know when n is even, how to calculate? So, okay, the detailed explanations are given in our session recordings and preparatory videos. Please subscribe to our StudyMEDIC group. Now interquartile range is always used along with median, and it is used when the data is not normally distributed. Okay, so again, for the detailed explanation, please subscribe. Now, what are the graphs that they ask us to identify, and when these graphs are used? Let us see one by one. The most common graphical representations. The first common graphical representation is the histogram. As you can see, on the x-axis, we are representing a continuous variable, and on the y-axis, we are representing the frequency count of this continuous variable. Here you can see the body weight is represented, okay, and we have divided this body weight into ranges. Okay, you can ranges, right? So 500 to 1000 was one range, 1000 to 1500, 1500 to 2000 grams, 2500. They are divided into class intervals. Now 500 to 1000, there are around, let us say, this many percentage of babies, 5%. And you can see 2500 to 2000, this many percentage, 20% of baby are there in the data, etc., etc. So you can see these class intervals, because it is a continuous variable, baby weight, are continuous and there is no gap in between. So when we plot these continuous variables in class intervals on the x-axis and their frequency distribution on the y-axis, what we get are the bars which are attached with each other. And this type of graph, which represents the continuous variables and along with the frequency distribution, is called as the histogram. And when we connect this middle of this all, we can also find out whether the distribution is normal or skewed, right? So this is histogram. So further, how to find out whether the distribution is normal or positively skewed, what is a negatively skewed graph? Please subscribe to our detailed StudyMEDIC library. The next graph, as we can see here in the x-axis, we are representing either a categorical variable or sometimes we can represent the discrete variables also, and the count is represented on the y-axis. Now, because this is a categorical variable, there is no connection, and if it is a discrete variable, it is not continuous, there is no connection between these bars. Then such a graph is called as bar graph, which is used to represent the discrete or categorical variable in x-axis and the frequency distribution on the y-axis. So these are the graphs that they will ask us to identify, and when they are representing what they represent is also what is asked. The next type of graph most commonly asked is called as the scatter plot. So you can see on one axis we are representing weight, a continuous variable, on another axis we are representing height, another continuous variable. These two are bivariate variables which are related to each other. Now, if you would like to know how they are related, as you can see, if this is the particular weight, then what is the height? So there is one scatter here. Similarly, there are other scatters. So you can see how. So it is linearly related here. Now, such plots where bivariate variables are represented is called as the scatter plot. So what are the scatter plots used? They are used to represent the bivariate variables. What does it show? It shows the strength and direction of the relationship, also called as the association between the two continuous variables. Okay. Now, how to find out how this strength and direction, whether it is positive, negative, weak or strong, the detailed explanations are available in our library. Please do subscribe. The next plot is the box whiskers plot. The next plot is the box whiskers plot. Now you can see in the box whiskers plot, okay, there is a box here, square box. As you can see, the square box is there, and then there are whiskers, and then there are whiskers. Okay, so they are called, that's why it is called as the box whiskers plot. Now, what does this represent? The centralmost line of this box represents the median. So what is the median diastolic pressure? Around 72 millimeters of mercury. Then the upper line actually measures the third quartile, around 78 millimeters of mercury, and the lower line of the square represent it is a first quartile, that is the 65 millimeters of mercury. And in between, if you take this range, it measures the quartile 3 minus quartile 1, which is called as the interquartile range. Whereas the upper whiskers usually measures the maximum and minimum values, and the outliers are represented as either star or something else, and it will be usually given in the graph. So this type of a graph is called as a box whiskers plot. This is used to depict the categorical variables along with its values on the y-axis, and also using this you can also find out the median and interquartile range. Also you can find out the distribution, what type of distribution it is. Such plot is called as box whisker plot. They may ask us to identify the plot and also calculate the quartile 3 minus quartile 1. Here it would be approximately be equal to 10 millimeters of mercury. So quartile 3 if it is 75, and quartile 1 if it is around 65. So you can see the quartile 3 minus quartile 1 is 10 millimeters of mercury. Now, how to find out the normal distribution and what are the other strong strength of this box whisker plots? If you want to learn, please subscribe to our StudyMEDIC library. The next topic is the normal distribution. This is a topic which is in between the descriptive biostatistics and inferential biostatistics. Now, what is this normal distribution? As we can see, if we plot again a continuous variable data set on the x-axis and we convert it into mean and then plot mean, 1 standard deviation, okay, mean 1 standard deviation, and mean 2 standard deviation, 3 standard deviation, minus 1 standard, 2 minus 2 standard, and minus 3 standard deviation on the x-axis. And on the y-axis, if you plot the probability density, what the graph we get is called as the normal distribution graph. And you can see this is also called as the Gaussian distribution graph, and it acquires a bell shape which is symmetrical on this right and left side, where always mean, median and mode are equal. Now, the most important thing about the normal distribution graph is that it always follows an empirical rule of 68, 95, 99 rule. What is the meaning of this? That means 68% of the data, 68% of the data, they lie within this data set points, that is mean plus or minus 1 standard deviation. Whereas 95% of the data, 95% of the data, they lie within this mean plus or minus 2 standard deviation data set points, and 99% of the data lie within the mean plus or minus 3 standard deviation data points. Okay, 99% will lie within the mean plus or minus 3 standard deviation data points. Now using this, how do we solve certain problems? For example, if a population mean is 25 and standard deviation is 2.5, then if you would like to find out how many in this particular population of 1,000 would probably require treatment of obesity, then what we would do? Then we will use this empirical rule and the characteristics of the normal distribution to solve such a problems. When you plot the mean, this is 25, right? And the mean is around 25. And what is the SD? SD is around 2.5. Then when we plot the mean plus SD, so this is the mean plus SD. So you can see it's the mean plus SD. Then when we plot the second SD, that is 30, and third SD, that is 32.5. Similarly, mean plus or minus 1 SD, 2 SD and 3 SD can be plotted. When we plot, we come to know that mean is 25 and 27.5 is the 1 SD and 30 is the. Now what is obesity? Obesity is usually BMI of more than, let us say, 30. Now we would like to know what percentage of this are more than actually 30. Now we already know that between, this is the plus 2 standard deviation. So between minus and plus 2 standard deviation, 95% of the data exist. 95%. That means 5% of the data are outside this. So since this is symmetrical, around 2.1 to 2.5% of the data, 2.1 to 2.5% of the data is more than plus 1 SD, and around 2.1 to 2.5% of the data is less than 2 SD. But we would like to know how much is more than 30. That is more than mean plus 2 SD is around 2.1% or 2.1 to 2.5%. That means 2.1 of 1000 is around 21 to 25 people actually are having BMI more than 30. 21 to 25 people are actually having BMI more than 30, and they would actually require the treatment. Similarly, how many are underweight? How to find out how many are underweight? How to find out how many are between 20 to 27 or 30? All this, okay? And also, sometimes they may ask how many if a BMI is given, or if cholesterol levels are given and mean cholesterol levels are given, how many would like to have a treatment? For the detailed explanation of this, okay, please subscribe to our StudyMEDIC library. The another high-yield topic is the confidence interval. Now, what is this confidence interval? Sometimes they ask definition of the confidence interval in the single best answers also. Now observe this. It is an interval. Okay, interval. That means two values are there. Range is there, which is calculated from what sample? The sample that we draw from the population. Using that we calculate. What do we use in that? We use sample mean and sample SD to calculate the particular range. Now, when this range is calculated, what does it tell? Now it tells us with a certain degree of confidence. What does it tell? A probability. For example, 95% probability is there that the population from which the sample is drawn, that population. The population parameters, if for example population mean birth weight, it lies within this confidence interval range. So we use the sample mean to know, to calculate a range, which will tell us what is the 95% probability that population mean will lie within this range. So in a way, we are giving an estimate of the population parameter. In a way, we are giving the estimate of the population parameter using the sample statistics. Using the sample statistics, right? Now, for example, in a study with a sample of 900 newborn are there, N is 900, mean birth weight is 2000 grams, and a sample SD of 120 gram was there. Now, from this sample, this is the population. From this sample is drawn, from which sample is drawn, we now know the data of the samples. We know the mean of the sample, SD of the sample, but we would like to know what is the mean of the population from which this sample was drawn. So for that we are calculating a per certain interval, right? That is the confidence interval. So what is the confidence interval for this? So what is the confidence interval? So now we will see what are the formula to calculate. We can also know that confidence interval can not only be calculated for mean but also for other different estimates. So what is this confidence interval? Confidence interval of mean is calculated as sample mean plus or minus 2 standard error of mean. What is the standard error of mean? It is the variation in all probable sample means. Okay, and it is calculated as standard error of mean is equal to sample standard deviation divided by square root of total number of sample size. So when we take the sample, we get the sample mean of birth weight, let us say, we get the sample SD of the birth weight, and we also know the total number. We have to calculate the standard error of mean. Now here standard error of mean is SD is 120, SD is let us say 120, and square root of, let us say, sample size is 900 is 30. So SD will standard error of mean is equal to 4. What is 95% confidence mean then? 900 plus or minus 2 into, let us say, 4. 2 into 4 is 8. Okay, standard error of mean 2 into 4 is 8. So it will be from 892 to 908 grams. What is the meaning? There is a 95% probability that the population birth weight, population mean of the birth weight is lying within somewhere between 892 to 908 gram. From where did it derive this confidence interval? From this sample data, summary sample statistics. So that is the confidence interval. Sometimes the other important things that the confidence interval tells us are the following. So what are those? We can also find out what is the effect of sample size on and sample standard deviation on confidence interval. We can also find out what is the relationship between confidence interval and precision of the finding in the study. What is the relationship between confidence interval and significance of the finding in the study? And what is the relationship between confidence interval and effect estimate? Okay, effect estimate or how much is the estimate size? Okay, effect size. Effect size of the particular study. We can also find out how much is the effect size of the particular study using the confidence interval. Now, how to find out this effect of sample size and sample SD and confidence interval, how to find out precision using confidence interval, significance using confidence interval, and the effect size using confidence interval. The detailed explanation are given in our StudyMEDIC library. So these are some of the various high-yield topics in this YouTube revision series on MRCOG1 related to the area of biostatistics. Some of the other high-yield topics are also there, and if you want to find out more details on these topics with the very good explanations and which are not covered, please subscribe to our StudyMRCOG group. And you can see we are offering various national as well as international courses. Once you subscribe, you will get a free access to our StudyMEDIC or StudyMRCOG library, whichever you subscribe. This library will have audio podcasts which you can listen to, preparatory videos that you can view on various individual topic wise, chapter wise, and then various session recordings are also available. Mock papers, interactive, freely available. Recall tests are available. Okay, and various other study materials are available once you subscribe. Hope this YouTube revision series was helpful, and thank you from myself, Dr. Avinash SS. All the best.